So 7-3, day 1. You have seen what sine and cosine answers look like, correct? And for the most part, if we are using the unit circle, did those answers end up looking very nice? You know, a lot of times they had a square root of 6 involved, a square root of 2 involved, and a 4. So keep in mind, you could always do tangent by finding sine of that angle over cosine of that angle, but then that's a lot of extra algebra that you're going to need to do, and basically another place that you could potentially make a mistake. But I'm not going to tell you that tangent is easy. Again, it's a sum and difference identity. The reason it's called that is because we're adding two angles together or subtracting them, sum and difference. That's why it's called that. And if we are looking for 105, I've chose 60 and 45 again. Are those the only two angles you could use to get 105? So there's a ton of them you could use. But what we're going to look at here is we're going to say, all right, to find tangent of 105, I'm going to take tangent of, now if we're using 60 and 45, how are we going to get 105? We're going to add them. So does it matter which one I put first? Not really. So we'll just put 60 first, seeing it's listed first right there. So in other words, this is kind of, you could look at it this way, as our x and y, if you wanted to look at it that way. So what we're going to do is substitute that information into the formula that's up here. So this one right here says take tangent of the first one, so tangent of 60 degrees. Do you agree with that? Okay. Now, we have to be careful. That symbol right there and that symbol right there, do I switch the sign or keep it the same? Keep it the same. So this one here said plus, so I'm going to write plus. And then tangent of the second one, which is 45 degrees. So that's the numerator. Do you agree with that? Any questions about that? No? All right, so on the bottom, that one is just a 1. But now, yeah, compare the symbol out front now with this one on the bottom. You do have to switch whatever the sign was. And over here it's plus, so here it will be minus. And then tangent of 60 times tangent of 45. Keeping in mind, you could always just go to sine and cosine, put them together, do that algebra if you wanted to. What I hear some of you kind of scrambling for in your folders, and probably not a bad idea, is your little table that has some of those values for you. You already figured them out, right? Tangent, cotangent, secant, we already figured all those out. So why don't you go ahead and pull out that little table you have so that we can do this a little quicker. I'm hoping, I'll be honest with you, I'm hoping you all know tangent of 45 without looking it up. I'm hoping you're getting to that point, or it's something you can figure out real quick in your head, because that one actually works out fairly nice. But how about tangent of 60? Has anybody found their sheet that has that in? Is it the square root of 3 over 3 or just square root of 3? Okay, so tangent of 60 is just the square root of 3, so that works out pretty nice. Plus, how about tangent of 45? Again, I really hope you're kind of getting that one. It is 1. And remember, that's because it's square root of 2 over 2 over square root of 2 over 2 works out to be 1. And here we have 1 minus, well, tangent of 60 is, it's still the square root of 3. It hasn't changed since the numerator, right? It's still the same thing. So square root of 3, which I'm going to have to take times 1. Well, that's kind of nice. Unfortunately, you might be looking at this saying, oh, that's not too bad for tangent. But then look at your little chart. Are some of tangent's answers not necessarily all that nice? Like, is square root of 3 over 3 on there? It is, and are there some other really not nice answers? There are, and so that's where you're going to run into trouble with tangent. Is there a whole lot I can really do with the numerator here? Not really. Over, well, this right here is pretty simple. That's just square root of 3, right, if I multiply those two numbers? So it's 1 minus the square root of 3. Are there any questions how I got to that answer right there? Square root of 3 plus 1 over 1 minus the square root of 3. That would be great if I was going to allow you to circle that answer. Yeah. And you know, the best part is if you want to find out when I don't really care about radicals in the denominator, take calculus. I'll let you leave them down there most times. But you're not in calculus yet, and so we got to take care of that. So we have to multiply by 1. We can't multiply by anything else or we're changing the value. Well, square root of 3 over square root of 3 over square root of 3 would almost be correct, And I'll show you why. Just don't write this down. I'll show you. I have to distribute that, and so I still have a square root of 3. So you're close. But I think somebody was already saying what we needed to do. We are going to set up a difference of two squares on purpose. Right here, difference of two squares when we FOIL it out, because it'll take care of the radical. Notice all I did is I took the exact same two values, and this one said minus, so over here I put plus. What if this one would have said plus here? I would have put minus over there. But if that's what I'm multiplying on the bottom, this is just an extra scribble, sorry about that. What should I multiply by on top? Same thing. Now some of you are saying, oh, we got to FOIL the top and the bottom. Well, I mean, you can if you want. I personally am not going to. Because here's how I view the top. I view the top as, isn't it the square root of 3 plus 1 times itself? Isn't that really what it is? And that's how I will let you write that. So I'm saving you a little bit of work. You don't have to FOIL the top. But I am going to expect you to FOIL the bottom. But if we've done this right, we just took the complex conjugate, that's what this is called. The radical should go away, if we did it right. Now you're wondering, why did we set up the difference of two squares? Hopefully it'll start ringing a bell when you see it again. 1 times 1, is that okay? Yeah, that's just 1. Now when I take this one, it's 1 times this positive square root of 3, which is positive square root of 3. And then what's the very next thing I'm going to do? I'm going to cancel it off by the very next thing I do, by taking negative square root of 3 times that, so it's negative square root of 3. So that radical is taken care of, right? But what about this last radical? How does that go away? If I take this negative square root of 3 times positive square root of 3, it's negative square root of 9. So how does that radical go away, though? Oh, we know what that is. It's not imaginary because the negative's on the outside. I'm going to write it up here because I'm running out of room. Over it is negative 2 because it would be 1 minus 3 or negative 2. Once again, that's the exact answer. Could we very easily have typed tangent of 105 into our calculator in degree mode and it would have given us a decimal? What I'm telling you right now is if you type that into your calculator, you will get the exact same decimals. Does tangent of 105 make sense that that answer is negative? Because 105 is in which quadrant? Is tangent negative in the second quadrant? Yes, it is. Okay. And that's why we saved tangent for a separate day. Because let's face it, these numbers here actually weren't looking too bad. It was looking pretty easy at this point until Algebra 2 found its way into advanced math. Okay. Any questions on that? I think now that you've seen that one, you can probably handle the rest of them. But what we're going to do here is everybody's favorite word, verify. So we have to get the left side look the same as the right side. I think you're going to find these to be easier than the previous verify. Verify means to get the left side and the right side identical. Are they right now? Boy, that'd be an easy verify if they were. But tangent has a little rule. Do you agree with that? There's a difference right there. It's pi over 2 minus x, right? That's the angle. Well, we just learned a little rule back here for that. I'm going to give you a little helpful hint. On verify problems, I believe using tangent's rule to be very difficult. And so what we're going to do is we're going to be very tricky. It's not that we're cheating the system, we're just being very tricky. This left side, yeah, that's cotangent, but we're going to rewrite the other side. We're going to rewrite it into something perhaps we're a little bit more comfortable with, which is sines and cosines. So be careful. Notice how I'm writing it. Kind of try and emulate what I'm doing here. There, I left myself plenty of space. the thing you have to remember when you're switching from tangent or cotangent or any of those to sines and cosines or whatever you want to switch it to, the angle has to remain. You can't just switch the angle to whatever you want it to be. In this problem, I think we can both or all agree that the angle is a little bit more complicated in this one than it has been in the past. The angle in this one is all of that. So that has to stay right here. That's a horrible pi. And then it also has to stay down here. Again, this is just my suggestion. If you really, really like tangent's new little formula, you can go ahead and use it. It's going to take you more time. So you need to make that choice. And what I need you to do now is take out yesterday's notes because we need sine and cosines formulas. Or yeah, it'd be actually Friday's notes. Or how about 7-3 day 1 notes?
April 7th. 15.